We're getting the exact values.
But what happened? Do you remember there was something that happened that threw us off?
Kansas.
We're on page 52, and we were doing problem. We were on page 52, and we were doing problem B, and we thought we had it all under control because our colored sheet has a formula on it for the tangent of an angle minus an angle. We flipped it over because this is a cotangent problem, and we were on our way. But then all of a sudden we ran into what issue? What happened? Undefined. So, kids, tangents don't work with pi over 2. Pi over 2 is 90. Tangents don't work at 90. You don't want to do a tangent problem when there's a 90 because 90 is the point 0,1, and when you put y over x, you're undefined. So if your problem has a 90 in it, then tangent isn't going to work ever. So the alternative, since I can't do problem B, I'm changing the pi over 2 into 90, is that okay? Since I can't make this a tangent, normally cotangent, I make that into a tangent. I can't. So what else can I make cotangent into? Besides the reciprocal of the tangent, what is the other thing that cotangent
Cosecant minus 1.
Now that's only if it's squared. If it were squared, I could do that. It's not. Cosine over sine. So you aren't going to like the looks of this, but we are going to have to do two formulas. Cotangent is cosine over sine. Doesn't matter what the angle is. In this case, the angle is 90 minus u, but it wouldn't matter. So cosine over sine. So now I'm going to do my formula for the numerator, which is a cosine. So look at your paper. It's the cosine of an angle minus an angle. What? Have you found the formula? Okay, what's it say? What do I do? Cosine of the first. Cosine of the second. Plus
sine of the first.
Sine of the first. Sine of the second. So there's your cosine formula. We talked the other day, and I'll reiterate, you cannot just distribute the cosine. It doesn't work. You can't do it. If you want to deal with this, you have to use your formula. Cosine, cosine minus sine, sine. Or plus sine, sine, I'm sorry. Now, what about my denominator? Do the same thing, but use your sine formula.
Sine the first, cosine
of the first,
minus
cosine of the second, minus cosine of the first, sine of the second. Very, very good. So on your colored sheet, what are we looking at? U's and V's. So this is your U and this is your V. Right? Okay. Now, let's go back to our unit circle. This is where we were the other day. And we're up here at 90. There's 90. Cosine is x, and sine is 1. So what happens when I plug that in? What do I have here? What's the cosine of 90? 0. And what's the sine of 90? 1. I gotta do the same thing on the bottom. The sine of 90, you just told me is 1. Oops, that's a minus. And the cosine of 90 is 0. So what does this simplify to? When I start, when I multiply by 0, isn't that just gone? So what do I have on top? Sine u, basically sine u. And what do I have on the bottom? That that's gone, so basically just cosine u. Wait a second, what's sine over cosine? Tangent. So this came out to be tangent, and I hope that's what I wanted. It is. Good.
Yay.
Everybody good with that? Now, you can do every tangent or cotangent problem this way. You can do every one by splitting up. You have to split up the ones that have a 90 or a 270. But you can split up all of them. If you don't want to try to keep it all straight, just split them up all the time. Cosine over sine, that's what cotangent is. Okay? All right. Next one is another little verify. Nothing tricky about it. Tans and cotans have trickiness, sines and cosines don't. So it's just a straightforward problem. Tell me what you think we should do.
Distribute the sine.
Okay, now be careful. We cannot, I don't know what you meant. We cannot distribute. Sine, S-I-N, does not distribute. You don't just do sine, sine. That isn't how it works. There's a formula for this. We just used it. What's the formula for the sine of an angle minus an angle?
Sine, cosine.
Sine first, cosine second, minus cosine first, sine second. This is your U and your V, guys. Right? Your U and your V. Now, all of that is just this. So now I'm going to do plus, and now I have to do the same thing with this one. What's that going to look like? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Good, I hear somebody over there telling me, good. So one more time, listen to me. Don't just distribute. You have to apply your formula. All right, what happens? Anything?
The sine x
Don't
and
these
cosine.
guys cancel? Don't you have one positive and one negative, and they're exactly the same? So they're gone. And speaking of exactly the same, aren't these two exactly the same?
Yes.
So if I have one of them and one of them, then altogether I have two of them. So 2 sine x cosine y. That's what I wanted. Okay. Now, you've never used these formulas before. I get it takes a little getting used to. Office hours available. Come in if you're struggling. This homework will be due, what's today, Wednesday? It'll be due on Friday. So 5-3 is due on Friday. Okay, we're going to start 5-4 today. Which is no big deal. It's just more formulas. So, if you look on your paper, the ones we were just using were these ones that have U plus V and U minus V in them, right? Those are the ones we've just been using. Now we're going to the ones underneath that have the 2 theta or the theta over 2. These are called, in 5-4, they're called the half angle formulas and the double angle formulas. So let's see how this works. Okay. Find the cosine of 15. Now, this is actually a repeat problem. I think we did this already. Anybody remember how we found? It could have been a sine, I don't remember. But how did we do it? What would we do to get the sine or cosine of 15 degrees? Oh, Alexis?
So we'd make it so that it'd be sine or cosine, and then the 30, 45.
Exactly. So for 15, we could do 45 minus 30, or we could do 60 minus 45, or there would be some bigger ones we could use if we wanted to challenge ourselves. Now, that's great, there's nothing wrong with it. But these directions specifically say use the half angle identities. So we need to think of the cosine of 15 as half of 30. So instead of thinking about 15 as 45 minus 30, that's a difference. We're thinking about it as half of something. It's half of 30. And when we think about it that way, then we use our half angle formula on your sheet, which says the cosine of half an angle, find that formula on your sheet. This is the cosine of half an angle, is plus or minus the square root of 1 plus the cosine of theta over 2. Well, if I'm doing 30 over 2, because that's what 15 is, then my theta is 30. So I have plus or minus the square root of 1 plus cosine 30 over 2. And now, either I have the cosine of 30 memorized, or I figure it out. The cosine of 30, I need to put a number in there, the cosine of 30. So if that's 30, that's 1, 2, root 3. And it's in quadrant 1, so I don't need to worry about any negatives. So what's the cosine of 30? Root 3 over 2. Oh my gosh. This may be the first time, I can't remember, that you've seen a radical underneath another radical. But it is perfectly okay. So don't panic about it. It's perfectly okay. What is not okay is having a big fraction with a little fraction in it. That is not okay. So to get rid of that, I am going to multiply everything by 2. That will cancel this. Do you see that? That's why I did it. So what do I have now under that radical? I got 2 plus root 3 over 4.
You can't simplify.
And that is a magnificent thing to have in the bottom, because what's the square root of 4? Just 2. So the top stays a mess. The top stays the square root of 2 plus the square root of 3. But now the bottom is 2. Square root of 4. You're okay with that? Now, you must choose whether you want the positive or the negative. You know enough about radicals. When you take the square root of something, it can be positive or negative, right? So you need to pick. This is easy. You're finding the cosine of 15. Where is 15? If I said draw 15 degrees, where would you draw it?
1.
In quadrant 1. And everything is positive in quadrant 1. So we want the positive root. And there's your answer. Well, Mrs. Ford, that looks terrible. I know, but it's okay. It's okay. I'm going to have to erase that to do the next one. Does anybody have a question about some number or something that I put up there? No? Okay, let's look at the next one. We're gonna do exactly the same approach, but this one is a tangent, and the angle is a different angle. So let's think about this. 67.5 is half of what? 135. I heard somebody say it. So here's my problem. I'm finding the tangent of 135 over 2. That's 67.5. Okay? Now look on your paper. This is half an angle. Half of an angle. So this one actually has more than one version for you to use. So if you don't want to mess with the radical, like we had a radical in this last one, no choice, had a radical. If you don't want to mess with it, you could use one of the other versions. So for example, you could use the one that says sine over 1 plus cosine. You have a choice on that one, and your cosine 2x. The double angle cosine and the half angle tangent have options. And you can use whichever one you want. So is that okay with everybody? What's my theta? In the problem I am doing, what's my theta? 135. So I have the sine of 135 over 1 plus the cosine of 135. Okay, with me? We're going to find numbers now to plug in here. So I'm going to draw 135, which is over here. What's my reference angle? 45. So 1 root 2. Caution.
It's always
Negative down here. What's the sign? The sign of that right there. What is the sign?
2 over 2.
1 over root 2 or root 2 over 2. You are exactly right. What about the cosine?
1 minus root 2 over 2.
It's going to be negative root 2 over 2. Is that all right with everybody? Now, just like the last one, we've got a big fraction that has little fractions in it. Can't have it. So I'm going to multiply everything by 2 again. Everything. Because what's that going to accomplish? If I multiply this by 2, don't those cancel? And all I have left is root 2. Now if I multiply that by 2, I just get 2. And this is going to be minus root 2. It looks better, but it still doesn't look good. What's wrong with it?
There's a root 2 on the bottom.
There's a radical on the bottom. So to get rid of that, we'll have to multiply by the conjugate, 2 plus root 2. All right, so here we go. On the top it's a distribute. So I'm going to get 2 square root 2 plus. What happens when I multiply root 2 times root 2? I get the square root of 4, which is 2. Remember, when you multiply radicals that are the same, like square root of 2, square root of 2, you just get 2. Square root of 7, square root of 7, you just get 7. Down here is a FOIL. So first, outside, inside, and last. It happens again on the bottom. When you multiply last times last, you're going to get negative 2. All right. right, so what have I got? This is like the never-ending problem. Let's see, what have I got here on the bottom? Do I just get 2 on the bottom?
Yes.
And now we can divide out a 2. So that'll leave us with root 2 plus 1. And that's it. That's the tangent of 67.5. Well, the next problem uses the same formulas, but it's a little bit different. It's a little easier, actually. Yeah, they have doing an arithmetic on these. Take a look at the first problem, 2A. Look at your colored sheet and see if you can figure out what this is a formula for. It's a square root. It's 1 minus cosine over 2.
Sine.
So forget the number, because you won't see the number on the paper. But what is that?
Sine theta.
Abby?
I was going to say it's the sine angle over 2.
Sine angle over 2. That's right. This is the sine of the angle over 2. In our problem, the angle is 47. So this is a formula for the sine of 47 over 2, which is the sine of 23.5. That's it. That's all you have to do. Figure out what is this thing a formula for. All right, look at the next one. Again, don't pay attention to the numbers. Look at what's happening. This is sine squared minus cosine squared. Now see if you can find that or something really close to that on your colored sheet. Anybody see anything like that? Yeah, Ollie?
So the closest thing to that is sine squared theta plus cosine squared theta.
Okay, so we definitely have sine squared plus cosine squared, which is 1. But this is a minus. So look at your paper again. You're right, sine squared plus cosine squared is 1. But let's see if there's something that has a minus in it. Alexis?
There is the cosine theta, which is the cosine squared theta minus sine
Right,
squared.
so on the paper, you actually have a minus, a squared minus a squared. What's the problem?
Cosine minus
Yeah. Is cosine squared minus sine squared the same as sine squared minus cosine squared?
No.
No, but they're related. Aren't they backwards of each other?
Yes.
Aren't they opposites of each other? So this right here, which is what our problem is the opposite of cosine squared minus sine squared. Now make sure that makes sense to you. Don't let me pull a fast one. This guy right here, the problem, is the opposite, or the negative, of cosine squared minus sine squared. If you distributed this negative, you get your problem. This is on your sheet. What is that?
Cosine.
That's the cosine of 2 times 87. Isn't this the cosine double angle formula?
Mm-hmm.
So this in the circle is the cosine of 174, check my arithmetic. But our problem was the opposite of that, right? So the answer is negative cosine 174. Mrs. Ford, that's tricky. Yes, it is. All right, last one in this section. Tell me what this is the formula for. Look at your sheet. You're not going to find 73s, so don't be looking for those. But look at that pattern. What's that the formula for? Tangent of 2 theta. And in our problem, theta is 73. So this is the tangent of 146. We're switching gears again. Before we do, does anybody have a question about that? Everybody see where that came from? Okay, good. Okay, so now we're going to solve an equation. Okay, so that tells me I'm in degrees. The domain here. I'm looking for all the possible answers where sine 2x equals sine x. I'm open for suggestions. Emma? You putting your hand up?
No.
Oh, shoot. Alexis?
So, there's something for like the sine 2x and 2 sine theta, cosine theta.
Stop right there. She is right on target, folks. She looked at this problem and she said, Mrs. Ford, one side of the equation has, the angle is 2x, and the other side of the equation, the angle is plane x. That is trouble. That's bad news. So she looked on her sheet. The answer is always on your sheet. She looked on the sheet and said, hey, there's a formula for this, and the angles are plane x's just like that one. So she changed sine 2x into 2 sine cosine. That's the formula. You don't need to understand that. It's the formula, okay? Now where do I go, though? I'm not done. I'm not close. What do you want to do now? Alexis, I love you, but I'm not calling somebody else. Someone else is going to talk today. Let me say it again. Someone else is going to talk today. Who's it going to be? Take a stab at it. Worst that can happen is you're wrong. Okay, whatever.
Can you subtract the sign over to the other side
Yes.
and then take the sign out?
Exactly. That is exactly what you want to do. Very, very good. So he said, let's subtract the sign over to the other side. Move this over and get our equation equal to 0. Isn't that what we usually do? Not every single time, but most of the time we want our equation set equal to 0. So we subtract the sign over. Now, did anybody think about dividing by sign? Okay, that is kind of a natural gut feeling, but you can't do it. Never divide by something with a variable in it. Because if it's a variable, you don't know what it is, and it could be 0, and you can't divide by 0. So division is not the way to go here, although I understand completely why you would want to do that. I get it. You can't do it. So instead of dividing, we're going to do what Ethan said, we're going to subtract. And then did you hear what he said next after we subtracted over? We're going to factor it out. And when you pull out the sign, you're going to be left with 2 cosine minus 1. Ethan, that's beautiful, thank you. Now, I'm going to hear from somebody else. What do I do now? I've gotten my 0, and I have factored. So what do I want to do next, Ollie?
You want to equal the sign x to equal it to 0.
Exactly. That is exactly right. Once you get the thing factored, you're going to set both of the factors equal to 0. We talked about some of these the other day. They didn't have the 2x in it back then. So this says sine is 0 or cosine is 1/2. Where do I find zeros? I do not find zeros in triangles. I find zeros on the circle. So I'm going to draw a circle. And since it's sine, I will be looking at which letter. Oh my gosh. You see all the screens there? You guys are doing this to me. Sine is y. It has been since day 1. It hasn't changed. Sine is y. So, where around this circle do you see a y value that is 0?
On the y-axis.
A y value that's 0. Isn't it here? And here. So those angles are 0 and 180. If I were in radians, I'm in degrees. If I were in radians, I would say 0 and pi. Now, this is not on the circle, or I shouldn't say that, it's on the circle, but it's not one of these. This, I can draw a triangle for. If sine is y, then cosine is x, and it's positive. X is positive here and here. Agreed? And the cosine is adjacent over hypotenuse. So this is a √3 over here. And how big is that angle right there? 60. So is this one. So what are the answers to this piece of the problem? X equals what? 60 is one of them. And this one's the other one. How big is he?
300.
300. We have done problems where we said -60 was the answer. Not this time, though, because we have to be between 0 and 360. All right, well, that was a good team effort. You did really well. Let's see about the next one. I'm not going to shut up for the period's over, people, so you might as well enjoy it. Here we go. Cosine 2x equals cosine x. So it's a very similar problem. Cosine 2x equals cosine x. Okay, so let's think about what we just did. And let's do the same thing. So what do you think, guys? Look back at the last one we did. What was the very first thing we did? Ollie? Oh, I'm sorry, I didn't see your hand up.
Identify the formula.
Okay, so what formula you want to use, Ollie?
So we can do cosine 2 theta equals cosine squared theta minus sine squared theta.
Okay, do you everybody understand what he's talking about? He said this is a 2x. So on your paper, there are formulas for the cosine of 2 theta. So that's what you're going to plug in here. This is one of the ones, though, that you have more than one option. Any one of the options will work. You cannot pick a wrong option. However, because the problem has another thing in it, and it's a cosine, I'm going to choose the version that says 2 cosine squared minus 1. That will save me a step or two later on. So do you understand my logic, why I'm thinking that way? Look at the formulas that you have. You have 3 versions. One of them has cosines and sines in it. One of them is all sines and one of them is all cosines. Since the problem has a cosine already built into it, I'm going to choose the version that has just cosines. So I have the same variable, in other words, all cosines. Okay? Perfect. All right, good job, Ollie. Now, Sophia, do you know what we might do next?
Subtract cosine.
Subtract cosine. Get your 0. And when I subtract it, I'm going to actually put it in the middle of the problem, hoping that somebody notices something about this. I move the cosine to the other side. Yes, Abby?
Did you factor the sign out?
Well, you can't take the cosine out. You can factor, but you can't take the cosine out because there's no cosine in this one. So when you factor, I erased it the last one we did, but when we factored, we took it out of everything, and that's what you want to be able to do. And since that's a plain 1, I'm not going to be able to do that. This does factor, though. This actually is a quadratic equation. This is the same, think about it now, look at it. This is the same as 2x squared minus x minus 1. Instead of having cosine x, if you just had a plain x, this would be 2x squared minus x minus 1. How does that factor? 2x and x, 1 and 1, plus and minus, right? Don't stare at me blindly. First year algebra right there, folks, and factor that. Now, translate it back into our equation. Instead of 2x plus 1, we'll have 2 cosine plus 1 and cosine minus 1. If you FOIL this right here, this back together, if you FOIL it, you will get 2x or 2 cosine squared minus 2 cosine plus 1 cosine minus 1. You can always FOIL it to check it, just like you do in regular algebra. All right, Gavin, what do I do now? I'm here. This is where I am. I have it factor. So what do I do after I factor it?
I'm not sure.
Okay, look at the one we just did on the previous page. 3/6, sweetie?
A little bit, not right.
Okay, so once we got it factored in, and that one all we did was take something out. We just factored out a sign or something. But what did we do right after that? Did you write it down?
No.
write down everything, Gavin, okay? Donovan? Set each one equal to 0. So we're gonna set our factors equal to 0. All of these equations, I mean, they're all gonna have different numbers and stuff in them, but they're all gonna be done the same way. Use a formula to get rid of the 2x. Get your equation set equal to 0. Somehow factor it. Set the factors equal to 0. And then solve. So cosine equals -1/2 or cosine equals 1. I erased my circle, but somewhere on the circle, that's where you see the ones are on the circle. Somewhere on the circle, the cosine is 1. I'm doing this one first. Where is cosine 1? Cosine is x, and x is 1, only one place. 0. So the answer to this one is 0 degrees. That's the answer to that one. Cosine is not 1 over here. Cosine is -1 over here. Now, where is the cosine negative? Well, remember, cosine is x. X is negative over here, right? Cosine is adjacent over hypotenuse. I think I just did this. So this is √3. And how big is my reference angle? Not my answer, but my reference angle. 60. So these are both 60s. 60 is not an answer to the problem though. This would be an answer. How big is that red angle? 120. And then, how big is my orange angle? 240. So for those of you who are still sleeping, although now that the dinger's gone off, you're probably wide awake. This is 180 minus 60 and 180 plus 60. So the answers to the problem are these 3 numbers right here. Okie dokie, Smokies. Do I see you Friday? We'll quiz next time I see you. We'll practice it tomorrow. But I don't know when I see you. Okay, perfect.